Good morning, everyone. My name is Gwen, and today I'm here with my team members Christopher Tai, Karen Tanya, and Lee Minian to discuss about IKEA business in general and subsequently model and enhance its logistic operations. But before delving into the contents, I want to provide a brief introduction. Throughout the presentation, our team will examine IKEA, which serves as a major player in the home furnishings industry worldwide, with an emphasis on identifying and improving one of its key business operations. Our group seeks to comprehend the current process, spot inefficiencies, and suggest strategic improvements by investigating the operational context of the company, particularly the logistics operations. Our strategy involves taking into account both internal and external elements to determine how any proposed changes would affect overall business performance. The goal is to create a streamlined procedure that maximizes productivity, lowers expenses, and enhances service delivery while staying in accordance with the operational objectives of the company and the competitive environment. IKEA was founded in Sweden in 1943 and has grown into a global leader in home furnishings by prioritizing affordability, sustainability, and customer centricity. The company's strategy focuses on providing fashionable, functional products at affordable prices, supported by efficient logistic operations. In today's digital society, technology is vital for enhancing these logistic processes, improving delivery speeds, and streamlining supply chain operations. IKEA's investment in digital tools and e-commerce facilitates a seamless customer experience, making it easier for customers to browse and purchase products online. By leveraging digital innovation, IKEA effectively manages its supply chain and customer interactions, maintaining a competitive edge in the market. Moving on to how the business relates to the tech sector, IKEA uses technology to enhance its operations and customer engagement while expanding its business. The goal of IKEA Data and Technology is to develop digital capabilities that benefit both operations and consumers. IKEA engages with the IT industry to improve customer experience, streamline logistics, and promote sustainability. In digital marketing, IKEA integrates e-commerce channels, allowing customers to browse and buy products online. Recently, they partnered with Alibaba to open an online store on Tmall, enhancing accessibility in China's digital market. The growing e-commerce market presents significant opportunities for companies like IKEA to capitalize on the increasing popularity of online shopping. Furthermore, technological advancements have significantly improved IKEA's logistical operations. The company uses automated storage and retrieval technologies to reduce costs in its warehouses and is exploring entertainment technology like drone performance to boost productivity. Collaborating with Amazon Robotics, IKEA aims to enhance accuracy and reduce errors in inventory management. Additionally, they use RFID technology to track objects in real time, improving pallet tracking, forklift activity monitoring, inventory management, and access control, ensuring safe item movement and timely restocking. Moreover, IKEA enhances the shopping experience and boosts revenue by using data analytics to provide personalized product recommendations and understand customer behavior. By integrating e-commerce, data analytics, logistics optimization, and environmental initiatives, IKEA improves customer experience and operational efficiency. Therefore, by embracing digital tools, IKEA managed to build deeper customer relationships as well as to maintain a competitive edge in an increasingly tech-driven market.
Thank you to my wonderful roommates for giving me the chance to have this moment to talk. My name is Christopher Tai, and in this slide, we'll be talking about the BPN diagram, process modeling of IKEA's logistic operation. To start, our process will focus on the logistics side of IKEA. In here, our logistics process uses multiple key steps from placing their orders or inquiries to delivering the goods. Over here, we have prepared 6 BPN net pools, with lists ranging from clients, ordering departments, store, employees at the physical store, dispatch officers, and finally, the truck driver. Starting off, the clients mix their orders in which they choose from the online shop or application. Next, the online order goes to the ordering department in which they create a hard copy for logistic users. Once they made the copy, they then send the details and requests of the stock availability. The store or warehouse will then confirm with the employees at the physical store whether it's available to send. If the store does not have stock in hand, they will then have to make a request to the main factory in regards to the availability. Once everything settles, the employee will go through the dispatch officer for delivery ability. When everything is ready to process, the dispatch officer will then receive the order from the physical store and check the weight and scale of the items to see if it meets the requirement. If it doesn't, it must be sent through a third-party services. Lastly, the truck driver will receive the order details and stock from the dispatch officer. He will then start sorting routes for delivery to customers. Once they reach the homes, they will unload the items and request a sign-off from the customer. After that, if there's any additional orders, he will continue sorting out routes again. Once the orders finish, the process ends. For the next slide, it is the breakdown of every process of logistics that I mentioned earlier. In here, there are process descriptions for 11 different types of processes, from customers placing their orders to then receiving their orders at the end. It also has the description and details of inputs, outputs, external services, and technology dependency. To start, once our customers make their decision to purchase it, it will then be received by the ordering department and quickly move to requesting stocks from the store. Once it's confirmed, the store will then provide the details and cost of the shipment to the customers. Next, the shipment will be then passed to the dispatch officers to scale and weight it. After that, it is then passed off to the delivery drivers to make the shipment. Once it reaches the customers, it will be then signed off by them. The process ends once there is no more orders. For proposed process module, Not going much in detail, but the highlights that is shown here will improve the flow of the process here. As you can see, there are 4 proposed ideas that we have suggested that will improve the process flow. In the next slide, as you can see, it shows the improvement in the proposed process module. In the current process, it's shown to have too many processes that will be slowing down the flow, in which the term bottleneck comes to show. For the improvement, not much has changed, but the delivery process had increased with this suggestion in mind. Moving on to the next slide, the type of data that the process is reliant on. IKEA relies heavily on OLTP technologies to manage real-time transaction data, inventory management, ordering process and customer transaction, and supply chain management. In the first one, inventory management, OLTP systems can help track inventory across warehouses and stores, updating stock levels instantly as purchase and shipment occur. This helps to properly keep track of everything that is going around in the warehouses, so there is no confusion later on in the logistics area. Order processing and customer transaction, OLTP system process customers transactions, order confirmation and payment for online orders. This helps track the history of said customers ordering and their transactions. Number 3, supply chain management. OLTP system provide communication across IKEA supply chain partners, ensuring timely data interchange on stock level, shipping, and order fulfillment, which is crucial for logistics and product availability. Okay. As for the next slide, the type of data that the process is relying on, IKEA heavily relies on OLTP technologies to manage real-time transaction data. The first being inventory management, order processing and customer transaction, and lastly, supply chain management. Inventory management is there to help IKEA track their supplies and their stocks, whether they have this in mind, and how much they have on that item. The second one, order processing and customer transaction, is the process of keeping the transaction history and the processes or the ordering processes of the customers to help IKEA better remember what their customers' needs and wants are. As for the last one, supply chain management, it is to help IKEA to keep track of their supply chain partners, ensuring that they meet the proper time requirement to pay and the proper time to receive those raw materials from those supply chain partners. Thank you.
Here's a breakdown of the IT requirements essential for IKEA's sustainability logistics. First off is network requirements. Network requirements include high-speed internet and 5G to support real-time data transfer across logistics operations. Secure VPNs and a cloud-based network are also needed to protect data as it moves globally. For hardware, IoT sensors track real-time data on inventory, energy use, and vehicle location. Data servers and storage handle large-scale data processing, while renewable energy equipment like solar panels and EV charging stations align with IKEA's environmental goals. In software, ERP systems like SAP or Oracle integrate logistics and inventory management. AI-driven predictive analytics help with accurate demand forecasting and optimal routing, while fleet management software monitors vehicle efficiency and emissions. Finally, cloud services such as AWS and Azure enable real-time data analytics and secure storage. These services also ensure data backup and recovery to protect against disruptions. Together, these components enable IKEA's logistics to be both efficient and environmentally sustainable, meeting their operational and climate goals. So the question is, are external service technology providers used in the process, and who are they? Yes, external service technology providers are integral to IKEA's sustainability logistics process. They enhance efficiency and scalability, helping IKEA meet its complex operational and sustainability goals. These providers offer essential services in areas such as cloud computing, IoT solutions for tracking and monitoring, AI analytics for predictive insights, and renewable energy infrastructure for reducing carbon emissions. By leveraging these technologies, IKEA can optimize its logistic operations, reduce costs, and advance its sustainability targets effectively. To drive sustainable logistics, IKEA relies on 3 key technology providers. First, cloud service providers like AWS and Microsoft Azure help store and process large volumes of data, providing IKEA with real-time insights and scalability, all while reducing the need for internal infrastructure. Next, IoT and edge computing providers such as Cisco IoT enables real-time data collection from vehicles, warehouses, and renewable energy resources. This technology supports route optimization, energy monitoring, and helps improve delivery efficiency. Lastly, data analytics and AI providers like IBM Watson offers advanced analytics for emissions tracking and demand forecasting. This improves IKEA's decision-making, aligns with sustainability targets, and supports its carbon reduction goals. Together, these providers form a powerful foundation for IKEA's sustainable logistics strategy, helping the company reach its environmental objectives more efficiently.
Next, I'll be talking about the suggestions for improvement. First suggestion is floating warehouses with renewable energy. IKEA could revolutionize its logistics and sustainability initiatives with floating warehouses powered by renewable energy. Addressing land scarcity in coastal urban areas, these modular floating facilities would eliminate the need for costly land acquisition while positioning inventory closer to cities. Strategically located on coastal waters, these mini fulfillment centers would expedite deliveries using electric or solar-powered vessels, ideal for IKEA's bulky products. This approach would enhance customer satisfaction through faster delivery, providing a competitive edge in high-demand areas. Floating warehouses would rely on renewable tidal, wave, and solar energy, reducing IKEA's carbon footprint and aligning with its environmental goals. By operating off-grid and incorporating low-emission delivery vessels, this system would minimize road transportation, lessen urban congestion, and bolster IKEA's reputation as an eco-conscious innovator. These bold moves positions IKEA as a leader in sustainable logistics, appealing to environmentally conscious consumers and setting a new standard in the retail sector. Second suggestion is autonomous delivery system. IKEA could enhance its logistic operations by employing an autonomous delivery system using autonomous electric vehicles or AEVs for urban furniture orders. This approach addresses the challenges of urban environments and improves the delivery experience for online customers. AEVs are particularly beneficial for transporting large, cumbersome items like furniture, which are traditionally difficult and costly to deliver. Operating continuously, these vehicles optimize logistics by bypassing traffic patterns and reducing delivery times during peak hours. Tailored for IKEA's sizable products, AEVs improve delivery efficiency by minimizing delays and overcoming logistical challenges in densely populated urban areas. As electric vehicles, they align with IKEA's sustainability goals by reducing emissions associated with traditional delivery trucks, meeting consumer demand for eco-friendly practices and convenience. In addition to environmental benefits, autonomous delivery offers long-term cost savings through reduced reliance on human drivers, better route optimization, and lower operational costs. This system enables competitive delivery options such as same-day or next-day service, enhancing customer satisfaction. By adopting this technology, IKEA can position itself as a leader in logistics innovation, offering a scalable and sustainable delivery solution that meets the evolving needs of urban consumers. Moving on to the third suggestion is self-charging electric vehicle using kinetic pavement. This cutting-edge solution involves installing kinetic pavements along high-traffic routes near IKEA's distribution centers or key delivery paths. These specialized pavements capture energy from the movement and weight of vehicles, converting it into electricity to charge IKEA's electric delivery trucks during their journeys. By using energy generation pavements, IKEA could create a self-sufficient and eco-friendly logistical system. As delivery trucks drive over the kinetic surfaces, the generated electricity can be used to charge vehicles immediately or stored in nearby charging stations. This reduces dependence on traditional charging infrastructure and increases the efficiency of long-distance electric vehicle transportation. Investing in kinetic pavements would lower long-term operational costs while creating a scalable logistics network to meet growing demand. Finally, the fourth suggestion is solar-powered airships for long-distance transport. IKEA could transform its long-distance operations by adopting solar-powered airships for cargo transportation. These airships use solar energy during the day and renewable fuels like hydrogen or biofuel at night, offering a low-emission solution for intercontinental shipping. Unlike traditional freight methods, solar-powered airships require minimal fuel due to their reliance on solar panels and renewable energy, significantly reducing emissions from long-distance transportation. A key advantage of these airships is their ability to carry substantial weights with lower fuel consumption compared to conventional cargo methods. While slower, their efficiency in transporting large volumes across long distances makes them ideal for bulk shipping. Solar-powered airships also enable IKEA to access remote areas with minimal logistical constraints, requiring little infrastructure. They are well suited for transporting goods to and from isolated regions. This approach provides a forward-thinking, sustainable solution to meet the growing demand for environmentally responsible global logistics.
Next, I'll be highlighting the value and benefits of IKEA's updated sustainable logistics process. First, we have reduced carbon footprint. By using renewable energy, electric vehicles, and optimizing delivery routes, IKEA lowers CO2 emissions and supports its goals of being climate positive by 2030. This approach also appeals to environmentally conscious consumers. Next, cost savings plays a key role. The updated process reduces operational costs related to fuel and energy, ensuring long-term financial sustainability. Additionally, the savings created can be reinvested into further innovations. Finally, enhanced customer satisfaction is a significant benefit. With real-time tracking and faster deliveries, IKEA improves accuracy, reliability, and overall customer experience. This strengthens brand loyalty and reinforces its reputation for sustainability. Overall, these benefits will drive both environmental and operational improvements for IKEA. As IKEA adopts new technologies in its sustainable logistics process, several concerns need to be addressed. First, there are cybercrime risks. With more digital touchpoints, the system becomes more vulnerable to cyber attacks, which could disrupt operations, steal sensitive data, or manipulate supply chain information. Next, privacy issues arise with the collection of real-time data. This includes tracking customer deliveries and vehicle locations, which raises concerns about data privacy. IKEA must comply with regulations like GDPR to protect customer information. Finally, security threats increase as more processes becomes automated. This creates higher risk of data breaches or system failures, so ensuring robust security for IoT devices, autonomous vehicles, and cloud systems is essential. To mitigate these concerns, IKEA needs strong cybersecurity measures and data privacy protocols in place. In conclusion, IKEA's sustainable logistics innovations have the potential to greatly reduce environmental impact and improve operational efficiency. However, challenges like high initial costs, technical limitations, and cybersecurity risks need to be managed. With careful planning, investment in security, and regulatory compliance, IKEA can successfully achieve its sustainability goals while maintaining operational integrity and customer trust. That's it for our presentation. Thank you for paying attention to us.